everyone, my name is Emily Baldow, and today I'm going to be presenting on celiac disease. Celiac is a relatively prevalent disease. Around 1 in 100 people have it. 1% of the world's population has it, although it's estimated that actually more have it. They are just currently undiagnosed. It is an autoimmune disease. An immune response is initiated in someone with celiac when they ingest gluten. Those likely to have it include people who have family members that have celiac, women, white people, those with Down syndrome, and those with Tourette's. Currently, there is no cure for celiac, although there is a treatment for it, which just includes a gluten-free diet. Some other names that you may have heard celiac referred to by include celiac sprue, gluten-sensitive enteropathy, and non-tropical sprue. Signs and symptoms of the disease include constipation, diarrhea, bloating, fatigue, skin rashes. It's said that it's actually very hard for doctors to know to test someone for celiac because the signs and symptoms are so diverse. It is known as an organ-specific disease. However, some researchers and scientists have called it a systemic disease because it does certainly impact the entire body, but the immune response is initiated in the small intestine. This is an overview of what I will be covering in this presentation. This is sort of a simplified version of what occurs in the immune response of people with celiac. Gluten is a protein. It is made up of smaller protein subunits. Gluten is what celiac people cannot eat. It is what sort of triggers or initiates the entire immune response in people with celiac. Gluten is made up of smaller subunits. A couple of smaller subunits that it's made up of include glutenin and gliadin. Gliadin is actually very hard for humans to digest, and so even after digestion, it remains sort of a larger molecule. That larger molecule is actually able to sneak through the intestinal epithelia of people with celiac and enter into the space called the lamina propria. In the lamina propria, transglutaminase, which is an enzyme, is present. Transglutaminase binds to the gliadin and deaminates it. This deamination of the gliadin causes it to have increased binding affinity for antigen complexes on antigen-presenting cells. In this picture, you can see the gliadin sneaking through this intestinal epithelia and into the lamina propria space and binding to this transglutaminase. Transglutaminase cleaves it, and out come these cleaved gliadin molecules. So once the gliadin molecules have been cleaved, they then bind to antigen-presenting cells. These complexes that I mentioned before that are on the outside of antigen-presenting cells were encoded by specific gene variants present in people with celiac. Those gene variants include HLA-DQA1 and HLA-DQB1. And again, these genes encode the proteins that make up these complexes on the outside of antigen-presenting cells in people with celiac disease. However, I should note that not all people with these genes have celiac. In this upper right corner, I have a picture of sort of what those complexes look like. And right here, I have a picture of what that antigen-presenting sort of will look like in the next step and what that antigen binding looks like in this step. So after the antigen binds to the antigen presenting cell, the antigen presenting cell is ready to present to T cells, so to cytotoxic, to CD4 positive T cells. So it binds to and presents to CD4 positive T cells, and once those T cells become activated, they release cytokines, and the cytokines continue on to perform other functions in that space, such as inflammation or activating other cells. You can kind of see in the picture up here that the antigen presenting cell is presenting to the T cell is releasing cytokines, which are going to activate some other cells in the area and perform other functions. I do have a picture of some functions of one particular cytokine that is released. That is the interferon gamma cytokine. It has several different functions, but some of them include inflammation, Th1 differentiation, increased MHC and MHC2 expression. Next in the immune response comes B cells. I have this quote here from, it was actually present in several different papers I read when making this presentation. It says, T-cell mediated immune disorder, which basically is saying that celiac is known as a T-cell mediated immune disorder. So B cells are often sort of forgotten when talking about celiac disease. However, they are very important and they do still play a role. The major role of B cells in celiac disease is producing antibodies. The exact mechanism of these antibodies and their function is still under research. However, they do know that B cells are important in this immune response because they did a trial where they removed the B cells and they noticed that the villi on the small intestine cells actually were not as destroyed if the B cells weren't present. So that does show that the B cells actually do play an autoimmune role in celiac disease. I have a couple pictures here. This shows the B cell releasing antigens. This one sort of shows the T cell presenting to the B cell producing antigens, or antibodies, sorry. Next comes IL-15, interleukin-15, and cytotoxic T lymphocytes. So the CD4 positive T cell immune response isn't necessarily, for lack of better terms, strong enough to cause the amount of damage we see in celiac disease patients in their intestines. So it was discovered that CD8 positive T cells actually play a role, and in conjunction with that, IL-15, interleukin-15, plays a major role. So interleukin-15 is a cytokine that gets released from cells that are in a stressed state. So I really liked this picture here because it shows these cells in the top right, very stressed. You can see they're red, there's like large spaces in between them, and gluten is clearly present, and they are secreting IL-15. IL-15 goes and activates CD8 positive T cells. CD8 positive T cells then go and begin lysing these inflamed, stressed cells. You can see from this how much the immune response can affect the intestines of people with celiac disease patients and how damaging eating gluten can be for them. So this is just the picture again of what the immune response looks like. I'm just going to run through it real quick so we can piece all the parts together. So someone with celiac eats gluten, gets broken down to glutenin and gliadin. Gliadin slips through those intestinal gaps in between the intestinal epithelia. It then binds to transglutaminase, which deaminates it. The deaminated gluten gliadin molecule binds to the antigen-presenting cell. Antigen-presenting cell presents to T cells. T cells release cytokines, which have many different functions. T cells can present to B cells. B cells release antibodies. IL-15 is secreted from stressed out epithelial cells. IL-15 activates the CD8 positive T cells. CD8 positive T cells attack the stressed out epithelial cells. I did want to mention in celiac patients, I mentioned it a little bit earlier, but they do tend to have poor junctions in between their epithelial cells in their intestines. And this is caused by a lot of different mechanisms, but I wanted to show that this is how the gliadin molecule actually slips through those barriers in between the epithelial cells, is that the junctions are kind of open wide and allow a lot of different things to get in, not just gliadin. And from seeing that, you can kind of understand how dangerous celiac can be if left untreated. It can cause a lot of poor absorption of nutrients, which can lead to a lot of different issues. Some issues include heart disease, gallbladder malfunction, infertility, liver failure, malnutrition. So you can understand from there why celiac is so dangerous, why it needs to be understood, and why those who have it need to seek help for their disease. These are my sources. Thank you guys so much for listening, and I hope you have a great day.